1. Southern Ocean current reversal, a catastrophic climate tipping point. 2. Antarctica's Saltier waters, the secret to global climate chaos. 3. Antarctic sea ice and terminal decline? Shocking new findings and global impact. 4. Antarctica's ice crisis, Greenland's ice loss magnified and hidden threats revealed. 5. Southern Ocean crisis, rising salinity threatens Antarctic ice and triggers climate feedback. 1. Southern Ocean current reversal, a catastrophic climate tipping point. Imagine a world where the oceans, our planet's lifeblood, begin to behave in ways never seen before. This isn't science fiction, it's happening right now. The Southern Ocean current has reversed direction for the first time in recorded history, signaling a potential catastrophe in the global climate system. But here's where it gets controversial. Could this be the beginning of the end for our current climate stability? This dramatic shift was confirmed by marine scientists at El Institut de Ciències del Mar, ICMCSIC, in Barcelona. Climatologist Ben C. summed it up succinctly on social media. The stunning reversal of ocean circulation in the Southern Hemisphere confirms the global climate system has entered a catastrophic phase. The reversal affects the Deep Western Boundary Current, DWBC, in the South Atlantic, a vital component of the Atlantic Meridional Overturning Circulation, AMOC. Normally, the DWBC pulls cold, nutrient-rich water from the ocean floor, playing a crucial role in regulating global temperatures and absorbing atmospheric carbon dioxide. However, in 2023, the current reversed its flow from northward to southward for several consecutive months, something that hasn't happened in over 3 decades of monitoring. Dr. Marilena Oltmans, the lead author of the study, described this as an unprecedented observation and a potential game-changer. She warned that the reversal could significantly impact the Southern Ocean's ability to store heat and carbon, potentially doubling current atmospheric CO2 levels by releasing ancient carbon stored in deep ocean reservoirs. This is not just about one current. The weakening of the Antarctic overturning circulation, a deep ocean process driven by cold, salty water formation near Antarctica, has slowed by up to 40% since the late 1990s. This slowdown might be destabilizing regional ocean dynamics more rapidly than previously thought, raising concerns about the future of the AMOC. The AMOC, often referred to as the Gulf Stream, brings warm water from the equator to Europe. If it were to stop, Europe could experience a mini ice age, with winter temperatures plummeting by 10 to 30 degrees Celsius. While scientists predict the AMOC will cease flowing by 2100, recent studies suggest this collapse could happen much sooner, perhaps even this year or within the next few decades. The implications are staggering. The ocean acts as a massive carbon sink, absorbing about 25% of all human-generated CO2 emissions. If the reversal of the DWBC weakens this role, it could overwhelm existing carbon budgets and make current mitigation strategies ineffective. As the ICMCSIC warns, the planet is sending us increasingly clear signals that we are crossing critical thresholds, marking a shift from chronic climate stress to acute systemic breakdown. This isn't the only alarming sign. The reversal coincides with an unprecedented marine heat wave in the Mediterranean. On July 4, a Spanish meteorological buoy recorded a sea temperature of 31 degrees Celsius, as hot as a lukewarm bath. The northwestern Mediterranean Sea is currently 6.21 degrees Celsius above the 1982 to 2015 average, creating what scientists call bathwater conditions in a historically temperate basin. Warmer surface temperatures could further disrupt ocean currents, amplifying the cycle of warming and instability. While ocean circulations have shifted in the distant past due to glacial cycles, this reversal is unique because it's happening in modern times due to human-induced climate change. It poses significant risks to monsoon patterns, fisheries, and sea levels in the Southern Hemisphere. In light of these developments, researchers are calling for urgent global attention and a re-evaluation of climate adaptation strategies. The Southern Ocean current reversal is a stark reminder that we are entering a new, more volatile climate regime. How will we respond to these challenges? What measures can we take to mitigate the worst impacts? These are questions we must address together. The stakes are high, and the time to act is now. Will we hearken to the warnings of our changing oceans, or will we continue down the path of inaction? The planet is watching, and it's time for us to listen. 2. Antarctica's Saltier waters, the secret to global climate chaos. The icy waters surrounding Antarctica are undergoing a dramatic transformation that could reshape our planet's climate systems. Imagine losing an area of sea ice the size of Greenland since 2015, a staggering loss that signals one of the most rapid environmental changes we've witnessed on Earth. But here's where the story gets even more intriguing. This shift isn't just about melting ice, it's about a surprising twist in the ocean's chemistry that could upend our understanding of global weather patterns. For years, scientists believed that melting ice would make the ocean fresher, creating conditions that fostered new ice formation. However, recent discoveries have revealed a paradox. The Southern Ocean is becoming saltier, defying decades of assumptions. This shift isn't just a minor fluctuation, it's a game changer. A team of researchers from the University of Southampton, in collaboration with Spanish scientists, used data from the European Space Agency's SMOS satellite to track changes in ocean salinity. Their findings? Surface waters south of 50 degrees south latitude are growing saltier, reversing a decades-long trend of cooling and freshening that once supported expanding sea ice. Dr. Alessandro Silvano, the study's lead author, calls this discovery deeply troubling. Melting ice should make the ocean fresher, not saltier, he explains. Yet the data shows the opposite, and this could have far-reaching consequences. The science behind this shift is both fascinating and alarming. When ocean water is fresh and cold, it forms a layer that sits atop warmer, saltier water below. This stratification traps heat, allowing ice to form and persist. But as surface waters become saltier, this delicate balance is disrupted. The saltier water becomes denser, sinking and allowing warmer, deeper waters to rise. This upward movement of heat melts sea ice from beneath, creating a cycle that makes it harder for ice to reform. The results are already visible. Antarctic sea ice has plummeted, and a massive open water area known as the Maud Rice Polynya has reappeared in the Weddell Sea, its return marking a stark departure from the 1970s. This is a clear sign of how abnormal the current situation is, says Dr. Silvano. If this trend continues, it could trigger lasting changes in the Southern Ocean, with ripple effects across the globe. Studying the Southern Ocean is no easy task. Its extreme isolation, violent storms, and long periods of darkness make traditional methods impractical. That's why satellite technology like SMOS has become a lifeline for researchers. Scientists at the University of Southampton and the Barcelona Expert Center developed advanced algorithms to measure salinity from space, overcoming challenges that have long hindered accurate data collection. Roberto Sabia of the European Space Agency emphasizes the importance of these innovations. Sea surface salinity measurements are critical for understanding climate dynamics, especially in high-latitude regions where salinity drives water density. The implications of this research go beyond Antarctica. The Southern Ocean acts as a global thermostat, regulating heat exchange between the ocean and atmosphere. As sea ice declines, more heat escapes into the air, fueling stronger storms and accelerating global warming. This feedback loop, where saltier water melts ice, which in turn exposes more ocean to absorb heat, could push the planet closer to a tipping point. But here's the catch: climate models have long predicted that melting ice would freshen the ocean, creating a balancing effect. This new study suggests those models may have underestimated the complexity of ocean interactions. We're seeing changes in the Southern Ocean that defy our expectations, says Dr. Silvano. We might be closer to a tipping point than we realized, entering a new state defined by persistent ice loss and a feedback loop we're only beginning to understand. The global consequences are profound. Loss of Antarctic sea ice isn't just a local issue, it's a threat to ecosystems, weather patterns, and sea levels worldwide. Species like penguins and seals, which depend on sea ice for survival, face habitat loss. Meanwhile, the accelerated melting of the Antarctic ice sheet could lead to faster sea level rise, impacting coastal communities. As scientists continue to monitor these changes, one thing is clear: our understanding of ocean climate interactions is still evolving. Alberto Navarra Garabato, a co-author of the study, stresses the need for ongoing satellite and in situ monitoring. These findings highlight gaps in our knowledge. Without continuous observation, we risk missing critical shifts that could reshape our planet. So, what does this mean for the future? Could the Southern Ocean's transformation trigger a cascade of environmental changes we're only beginning to grasp? And how do we reconcile these findings with existing climate models? The answers could determine whether we're on the brink of a new era in Earth's climate history. What do you think? Share your thoughts below. This is a conversation we all need to have. 3. Antarctic sea ice in terminal decline? Shocking new findings and global impact. A shocking and urgent warning: Antarctica's sea ice may be in irreversible retreat, and the reason behind it challenges everything we thought we knew. Scientists have discovered that the waters encircling Antarctica are becoming noticeably saltier at the same time as the continent's sea ice is vanishing faster than ever before. Since 2015, a staggering amount of sea ice comparable in size to Greenland has disappeared, and it has yet to recover. This represents one of the most dramatic environmental transformations the globe has witnessed in the last decade. But here's where it gets controversial. Typically, when ice melts, it makes ocean water less salty, fresher. Yet, contrary to expectations, satellite observations are revealing that the Southern Ocean's surface salinity is climbing, which spells trouble for the future of Antarctic sea ice. Saltier water at the surface behaves differently. It tends to lift heat from the ocean's depths, making it increasingly difficult for new sea ice to form and persist. Why does this matter so much? The loss of Antarctic sea ice extends far beyond the continent itself. Fewer expanses of sea ice mean that species like emperor penguins, which rely on ice for breeding, and krill, which feed on algae beneath the ice, are left vulnerable. Moreover, as sea ice shrinks, more of the ocean's stored heat escapes into the atmosphere, fueling stronger and more frequent storms and ramping up global warming. This, in turn, brings more heat waves to faraway lands and melts even more of Antarctica's vast ice sheet, accelerating sea level rise across the globe. And this is the part most people miss. Recent research shows that the Southern Ocean is not just warming and losing ice, it's undergoing a fundamental shift. There appears to be a self-reinforcing feedback loop at play, one that may have already tipped the system into a new, persistent state of sea ice decline. Let's break down how scientists piece together this puzzle. The Southern Ocean is one of the planet's wildest, least accessible realms, often shrouded in darkness and lashed by storms. Thanks to advancements in space-based monitoring and the deployment of underwater robots, which quietly measure water temperature and salinity far beneath the surface, researchers can now get a real-time glimpse of what's happening. Teams from the University of Southampton, in collaboration with the Barcelona Expert Center and the European Space Agency, developed sophisticated methods to analyze years' worth of satellite and subsurface data. When they charted changes in the ocean's saltiness, temperature, and sea ice over 15 years, they saw something truly remarkable. Around 2015, the Southern Ocean's surface salinity suddenly spiked as the sea ice began its precipitous decline. For decades, things had moved in the opposite direction, with surface waters growing colder and fresher, which had helped sea ice expand. To understand why a saltier ocean surface is alarming, picture the Southern Ocean as a layer cake. Normally, cold, fresh water floats atop a deeper layer of warmer, saltier water. This natural layering keeps the ocean's warmth trapped below, allowing the surface to stay cool and sea ice to grow. But as the surface becomes saltier, it grows heavier and sinks, disrupting this delicate balance. Heated water from below is drawn up, melting sea ice from underneath even during the coldest months. This vertical mixing also brings more salt up from the depths, setting off a relentless cycle that further inhibits the formation of new ice. This powerful feedback loop: more salt brings more heat to the surface, which melts more ice, leading to more heat absorption from sunlight, was dramatically illustrated during the 2016 to 2017 return of the Maud Rice Polynya, a massive hole in the sea ice nearly 4 times the size of Wales. Such events, once rare, may become more common as the feedback intensifies. Why should someone in New York, Sydney, or Mumbai care? Because what happens in Antarctica doesn't stay in Antarctica. Sea ice acts as a planetary mirror, reflecting sunlight out to space and helping regulate Earth's temperature. Its loss means more energy stays trapped within the climate system, which speeds up warming, triggers fiercer storms, and increases the risk of coastal flooding everywhere. The unraveling of Antarctic ecosystems, from penguins to krill, sends ripples through food webs that eventually affect us all. Here's a controversial point. For years, climate models predicted that a warming world would actually make Antarctic surface waters fresher, thanks to increased melting and precipitation, thus keeping sea ice relatively stable. These new findings thoroughly upend that assumption. The observed rise in salinity and the breakdown of the ocean's layered structure are clear signals that our understanding, and therefore our predictions, may be outdated. If our scientific models aren't updated quickly, we could be caught off guard by rapid, irreversible changes. And this part is still up for debate. What exactly sparked the 2015 salinity surge? Experts don't fully agree, and until we understand all the mechanisms at play, the urgency for more research only grows. Unfortunately, ongoing monitoring efforts are under threat from budget cuts even as the need for high-quality data has never been greater. Tracking these trends provides not just warnings, but critical tools for adapting to an uncertain climate future. Without them, how can we hope to prepare for what comes next? So, what do you think? Is the Antarctic's transformation a wake-up call, or do you see it differently? Do you believe the new findings overturn previous climate assumptions, or is there another explanation? Join the conversation below and let your voice be heard. Do you agree or disagree with these scientists' interpretation of the emerging evidence? 4. Antarctica's ice crisis, Greenland's ice loss magnified and hidden threats revealed. Brace yourself, Antarctica has lost an entire Greenland's worth of sea ice in just a few years, and what's happening beneath the surface is even more alarming. If you thought the world's iciest continent was safe, think again. But here's where the real shock sets in. The ocean surrounding Antarctica is becoming saltier at a pace that has stunned even the experts. This seemingly subtle shift is triggering a chain reaction that threatens not just the polar south, but the stability of our entire climate system. The Southern Ocean, which encircles Antarctica, is currently experiencing a rapid and unexpected transformation. In the span of a few short years, the salinity near the surface has shot upward, coinciding with a striking loss of protective sea ice. To grasp the scale, Antarctica has shed enough sea ice since 2015 to cover all of Greenland, a change so massive it overshadows most other environmental events of recent decades. And this is the part most people miss. The increase in surface salinity isn't just a symptom, it's amplifying the problem in a dangerous feedback loop. Let's break it down for those new to the science. For decades, Antarctic surface waters became less salty, a process known as freshening, helping sea ice expand and insulating the waters below. But now, that pattern has suddenly and dramatically reversed. Using highly refined European satellite observations, researchers from the University of Southampton mapped a sharp increase in surface salinity south of the 50 degrees latitude. This spike lines up directly with a dramatic retreat of sea ice and the astonishing return of the Maud Rise polynya, a vast, open water hole in the ice not seen at this scale since the 1970s. Imagine a gap nearly 4 times the size of Wales reopening in the Weddell Sea. This news, published in the Proceedings of the National Academy of Sciences on June 30, is making waves around the world. Dr. Alessandro Silvano, who led the study, explains the danger. Saltier water at the surface lets deep, hidden heat rise up more easily, melting sea ice from below. It's a self-reinforcing cycle. Less ice means more heat escapes upward, and that melts even more ice. The return of the Maud Rise polynya serves as a bold signal that Antarctica is entering uncharted territory. If the salinity continues to rise and ice coverage remains thin, the Southern Ocean could be permanently altered, with global consequences. Stronger storms, warmer seas, and shrinking habitats for beloved Antarctic species, like penguins, are just the beginning. Here's a bit of science for beginners. Normally, in the frigid south, cold, fresh water tops warmer, saltier layers deeper down. When winter comes and ice forms, the density difference, called stratification, weakens, letting these layers mix. That mixing brings up heat, which melts more ice from below, preventing further growth. Since the early 1980s, increased freshening created stronger stratification, trapping heat and allowing sea ice to flourish. But with new satellite and robotic float technology, scientists have uncovered a reversal of fortune. Now, rising salinity is breaking down that stratification, letting deeper heat rise and reducing ice cover to record lows. Giant patches of open ocean, known as polynyas, are reappearing. Here's the kicker, and it's likely to stir controversy. Until now, most climate models expected human-caused global warming to actually boost surface freshening and strengthen stratification, helping to preserve sea ice for longer. This new discovery upends that assumption. While we knew climate change would eventually reduce Antarctic sea ice, models predicted a slower, more gradual decline, says Dr. Aditya Narayanan, co-author of the report. Instead, we're seeing a sudden loss of sea ice, a crucial shield that reflects sunlight, which could speed up global warming even more. So, what does all this mean? Professor Alberto Navarra Garabato, another key member of the research team, says these findings reveal major gaps in our understanding of the rapidly evolving Antarctic system. We need to keep monitoring, using satellites and new ocean tech, to truly grasp what's driving these swift and unexpected changes. Here's a question for everyone: should we rethink our climate projections in light of this shocking Antarctic shift? Or do you believe our models will eventually catch up? Do you think this rapid sea ice loss is just the tip of the iceberg? Dive into the comments below and let us know if you agree with this research or if you see another side to the story. Reference: Rising Surface Salinity and Declining Sea Ice, a new Southern Ocean state revealed by satellites by Alessandro Silvano et al., published June 30, 2025 in the Proceedings of the National Academy of Sciences, DOI 10.1073/NAS.25004400122. The project received support from the European Space Agency. Stay ahead of tomorrow's breakthroughs. Subscribe to the SciTech Daily newsletter for more in-depth science updates. 5. Southern Ocean Crisis: Rising salinity threatens Antarctic ice and triggers climate feedback. The Earth's climate system is constantly changing, but sometimes these changes come with surprises that could significantly impact our future climate. And this is exactly what makes the recent discovery about the Southern Ocean so compelling and a bit controversial. But here's where it gets controversial: a shift in the Southern Ocean structure, detected through advanced satellite technology, could redefine what we thought we knew about global climate dynamics. Thanks to insights from Earth observation satellites, an international team of scientists has identified an unprecedented phenomenon, the first confirmed evidence of a transformation in the Southern Ocean state. This groundbreaking research was led by scholars from the University of Southampton in the UK and has been published in the prestigious journal Proceedings of the National Academy of Sciences, PNAS. A crucial partner in this effort was the Institut de Sciences del Mar, ICMCSSE, which developed innovative satellite observation techniques within the framework of the ESO-FRESH project, supported by the European Space Agency, ESA. The most startling discovery from this study is both alarming and unexpected. Since 2016, scientists have observed a consistent increase in surface salinity along the path of the Antarctic circumpolar current. This change in water composition indicates a fundamental shift in the balance of ocean circulation in the Southern Hemisphere. Specifically, waters that were once fresher, closer to the sea ice edge, are now being replaced by saltier surface waters. Antonio Turiel, an ICMCSSE researcher and co-author of the study, explains, "We are witnessing a real transformation in ocean properties in the Southern Hemisphere, something we have never seen before." Climate models typically predict that surface waters in the Southern Ocean will become fresher over time, but our observations show the opposite: an increase in salinity. This contrast between expected and observed trends raises critical questions about the impacts of climate change. While the broader scientific community debates the potential collapse of the Atlantic Meridional Overturning Circulation, AMOC, the Southern Ocean is undergoing its own significant transformation. Sea ice coverage is declining, and the upper layers of the ocean are becoming more saline. Such changes could have far-reaching consequences for the global climate system, possibly triggering feedback loops that are not yet fully understood. The team warns that this shift from fresher to saltier surface waters could accelerate interactions between surface and deeper, warmer waters. This process might enhance heat exchange from the ocean's depths, intensify the melting of sea ice, and even influence the release of carbon dioxide, CO2, into the atmosphere. These developments could intensify global warming and disrupt existing climate patterns. Achieving this discovery was only possible due to a recent breakthrough by the Barcelona Expert Center, BC, a research laboratory within the ICMCSSE specializing in satellite-based ocean observation. Historically, the Southern Ocean was nearly invisible to satellites because of its cold temperatures and the constantly changing, complex nature of sea ice. To overcome this challenge, the BEC team developed a new data processing tool specifically designed for the European Space Agency's SMOS satellite, tailored to handle the extreme conditions in polar regions. Veronica Gonzalez, a key scientist involved, states, "This new processing technology has allowed us to collect surface salinity data of unprecedented clarity and accuracy in this difficult region." She adds that this innovation has helped explain the rapid loss of Antarctic sea ice, a long-standing puzzle in the scientific community. Beyond shedding light on regional changes, this research prompts a re-evaluation of the Southern Ocean's vital role in regulating Earth's climate. The Southern Ocean is a crucial component in controlling planetary heat and carbon absorption. Disturbances here could set off chain reactions affecting other major circulation systems like the AMOC, with serious implications for climates in Europe and beyond. Recognizing the urgency to deepen our understanding, the BC has launched 2 new projects funded by ESA in 2025. One, called Arctic Flow, aims to study freshwater input and density variations in the Arctic Ocean. The other, CCI-OSHF, Ocean Surface Heat Flux, focuses on analyzing heat transfer at the ocean surface. Both initiatives seek to develop novel satellite techniques that will be essential for monitoring, predicting, and responding to the accelerating impacts of climate change. Estrella Olmedo emphasizes the gravity of these findings, stating, "Our planet is sending us increasingly unmistakable signals that we are approaching critical thresholds." And in this case, the Southern Ocean, a remote and challenging environment, has revealed significant changes thanks to advanced satellite technology. These tools help us see what was previously invisible, giving us a chance to understand and possibly mitigate some of the most urgent climate risks. So, is this recent shift an early warning sign of bigger upheavals? Or does it challenge everything we thought we knew about how the Southern Ocean and climate systems work? The answers are not yet clear, but one thing is certain: the more we learn about these remote regions, the more urgent it becomes to re-examine our assumptions and accelerate climate action.